In this video, let us look at how health index is being applied to voltage regulators. Let us start with looking at what degrades a voltage regulator. Now, the damage to the cellulose insulation inside the voltage regulator is a frequent mode of degradation. Due to oxygen, thermal stress, and moisture, the cellulose insulation inside the voltage regulator degrades. The foregoing factors are influenced by the unit's environment. Thermal strains can be caused by the voltage regulator's loading profile, and the voltage regulator's lifespan is influenced by the state of the oil surrounding the cellulose insulation. The oil would also oxidizes during normal operation. Oil oxidation produces water and acid. Water and acid hastens the decomposition of cellulose insulation by speeding up the rate at which the material reaches the end of its useful life. The tensile strength and ductility of degraded cellulose insulation are both very low. While brittle insulation may not cause end of life of the asset or the voltage regulator, the lack of mechanical strength can cause the voltage regulator to fail when the insulation no longer serves its purpose. And as a result, the voltage regulator's life is shortened due to cellulose insulation degradation. The voltage regulator's tap changing system is likewise prone to wear and tear. Degradation is usually caused by components that have aged. Contact wear, weak springs, and component breakage in the drive mechanism were identified to be the most common failure modes of the tap changers. Wear and tear on the connections reduces the lifespan of the voltage regulator's tap changing components, as worn contacts prevent the unit from operating properly. Arcing between changing contacts during the tap changing procedure contributes to oil deterioration. As previously indicated, oil deterioration reduces the tactile strength of the cellulose insulation, increases the risk of a voltage regulator failure. The following shown in front of you right now are some of the most often utilized voltage regulator condition assessment techniques, and they are the visual examinations, infrared measurements of PD discharge or partial discharge, check the moisture content of the oil, as well as testing the controls. Visual inspections of voltage regulators are a popular and effective method of detecting exterior anomalies, and any damage or faults in the voltage regulators, symptoms of oil leaks, evidence of mechanical damage or corrosion to conductors, the state of terminations, and the condition of the operating mechanism and controls can all be detected by a qualified service crew using visual inspections. Hot regions that would cause thermal stress can be tracked using infrared image scans. Measurements of partial discharge can also provide an early warning of impending dielectric failure. For checking the dielectric condition of voltage regulators, gas and oil and moisture content analysis are particularly useful instruments. So now let us go over the different categories that composes the health index for voltage regulators. So of course, the first one is the service age. With a rating of 4, it means that the voltage regulator is between 0 to 10 years. Rating of 3 is when the voltage regulator is between 11 to 20. Rating of 2 is when the regulator is between 21 to 30. Rating 2.1 is when it's 31 to 40 years of age, and anything that's above 40 years of age, we will rate the regulator with a rating of 0. Now, before we move on further into our course, let us take a brief look at our sponsor for this course. Now, as an engineer, especially when I first started in my career, I really felt overwhelmed the list of documents that we need to do on top of our technical work. Yet, these documents are very important in our career, as it is the more prominent thing that displays our credibility to management and to our clients if we so decide to become an engineer consultant, which is where the real actual money is. Now, I don't have these tools available to me when I first started my career, but now PM Milestone has created this package of all the professional templates that you need so that you can focus more on the technical aspect of your career. These templates are tried and tested by real professionals, so you should feel confident in using them in your career to present your best foot forward in front of your manager or clients. These templates are also updated periodically, and I think their last update is just 2021, so they're not going to be out of date or context to the present times, as these people are serious in getting the most professional product to meet your needs. They're also very confident of the quality of these templates too, as they offer you their product completely risk-free with 60-day money-back guarantee if you are not satisfied with it. So if you are interested in this product and would also like to support me in creating these courses on YouTube in the future, please check out their product using the link in my video description titled Course Sponsor PM Milestone 2.0. The second category is visual inspection. For a rating of 4, all components including electrical conductors, connectors, etc. are clean and corrosion-free and in good condition, and no external evidence of overheating or any other abnormality, and no sign of oil leaks, and everything just appears to have all been well maintained. Now, for a rating of 3, it means that there are normal signs of wear with respect to those conductors, connectors, etc. And then, of course, there are no signs of oil leak. In a rating of 2, it means that there is significant degradation of these components, but their overall condition is still acceptable. For a rating of 1, it means that one or more of these components, such as the conductors, connectors, or other of these components, are deemed as unacceptable condition. However, they are still repairable. Lastly, for a rating of 0, there are one or more of these auxiliary components in an unacceptable condition and cannot be brought into acceptable condition. The third category is oil testing, and for a rating of 4, it means the test results indicate excellent insulation condition and no indication of moisture, arcing, or overheating. For a rating of 3, tests just indicates a normal aging, so no concerns about insulation health. For a rating of 2, it means that the test indicate slightly above average but stable moisture content or the presence of arcing, overheating related gases, but just slightly above average, nothing significant. For a rating of 1, some of the test return actually indicates significant concerns about the insulation condition. And lastly, for a rating of 0, it means that 2 or more of the oil tests indicate rapidly deteriorating insulation condition. The fourth category is testing of controls. So for a rating of 4, it means that the test results indicates the operating mechanism and control are in good condition. For a rating of 3, it means that the test results indicate normal wear of control components. For a rating of 2, the test results indicate significant wear of these components, but it does not affect safe operation of the regulator. For a rating of 1, it means that the test results indicate an unacceptable level of degradation of control components, and it is requiring component replacement or repairs during the next scheduled outage. And last but not least, for a rating of 0, the voltage regulator operator controls are actually deemed defective, damaged, or degraded, and it is requiring immediate replacement. And finally, the last category is IR testing results. And again, this only has 3 ratings with a value of 4, 2, and 0 respectively. So for a rating of 4, it means that there are no hotspots detected in the regulator. For a rating of 2, it means that there are noticeable hotspots detected, but they do not jeopardize safe ongoing operations. And last but not least, for a rating of 0, it means that there are very serious hotspots detected in the regulator. As for the health index, almost everything is of equal weight besides oil testing. So the service age, visual inspections, testing of controls, and infrared scan results are all given the weight of 2. Whereas oil testing, we're going to dumb down the importance of that and just put a rating of 1 into that. So let us go over an example. Consider a voltage regulator of 8 years, in which the rating will be 4 in that category, with normal signs of wear, which is rating of 3, and in oil test it indicates normal aging, which is again rating of 3. And when testing controls, it indicates normal wear, which is a rating of 3, and IR scan results for the voltage regulator indicates no hotspots detected, so full rating, which is a 4. Calculate the health index of this voltage regulator. So we first calculate the calculated score, which is basically you multiply the ratings with the weight that it is being used to compose that health index. So in this case, it'll be equal to 31, and maximum achievable score will be 4 times the sum of the weights of the health index, so it equals to 36. So the health index equals to 31 divided by 36 times 100 equals to 86. And as mentioned in the fundamental section, a value between 86 to 100 is actually considered very good, and as such there might be very minor deterioration of some components and only normal maintenance are needed. Now, if you like this video, please don't forget to click like and subscribe to our channel. Our channel, the EE Bootcamp, has a wealth of knowledge regarding to the energy industry, so be sure to check it out. Also, this video is part of a playlist of the whole course, and so I've put the link to the playlist for this free course in the video description. As you may be aware, I'm a professional online instructor that teaches various topics regarding to the energy industry and offers certificate of completion at the end of each course. As you probably have noticed, this course needs fundamental knowledge in basic asset management. Physical asset management is important, and the skills are highly sought after in many large companies within the energy industry, or any industry that manages large asset in infrastructures for that matter. If you lack knowledge in physical asset management, look no further than my Physical Asset Management Fundamentals course offered at Electrical Engineering Portal, as in that course, I will provide you with the fundamentals that you need to kickstart your career in the physical asset management world. Another type of knowledge that you need for this course is fundamental information about the power distribution system. If you don't have enough experience in the industry, I would suggest you to enroll in my Distribution Power Engineering Fundamentals course hosted on Udemy, as in that course, I will walk you through the different parts of the power distribution system as well as basic design concepts that you will need to kickstart your career in the industry. Now, I have put the links to both of these courses in the video description also. Lastly, I have also included the link to my website in the video description that contains the information to all the courses that I offer, as well as other helpful resources that you may find useful in your career or in your learning path. Thank you, and I wish you good luck in your career. Remember, knowledge is power.